Okay, today we're going to learn how to program a Lego robot to drive straight. So the first thing you want to do is open up LabVIEW, and so I'm using 2014, and simply click Create Project. Once you click this, you'll be presented with a number of options, and we simply want to select blank VI. .vi is the extension used for LabVIEW programs, similar to how a Word document would be, say, .doc or .docx. So we're going to click blank VI. When you select blank VI, you're going to see that you have two panels here, your front panel and your block diagram. We're not concerned with the front panel for this particular program. You can just move that to the side. We do want to focus here on our block diagram. Now, before we get started with our program, LabVIEW is used for many different things and not just programming Lego robots. So we want to make sure that we are actually targeting this program so that it's specific for our Lego robot. And so what you want to do is just simply go up to File and click Target to NXT or EV3. So it doesn't matter whether or not you're programming with the NXT brick or the EV3 brick, but you do want to select this. And what you'll notice is when I select that target, down in the bottom left-hand corner, my robot, or my brain, is now identified, and I have this named as carbs, and it's currently connected through my USB cord. You'll also notice at the top up here that these options have now changed. We do have the run button, we also have the deploy button, and that's deploying to your robot. All right. Now, what we want to do is have our robot drive straight. And so in our functions palette, and if your functions palette is not open, simply click View Functions Palette, and that'll open up for you. We have three options here, and what we want to focus on right now is our I/O, or our inputs and outputs. And the first option to be able to program our robot to go forward is our motor move. So I'm just going to click and drag one of these on the screen. All right, this is the first part of my program. And if I hover over this, you'll see in my context up over the right, we have that the pink lines are what will allow us to link our next steps. And so we'll be using that shortly. We'll see that in this particular function, I also have an ability to modify my power or speed. And at the top, you see there's a small blue line here that actually allows you to identify where your motors are. So the first step we want to do before we write any more of our program is to identify where our motors are. So I've built a test robot here just for this demonstration. You can see on this particular robot I have two motors attached, one on each side. And if I look to see where they are attached, we can see that our cords here are attached to A and to C. All right, so we're going to be programming this particular robot to move motors that are attached to A and C. All right, so let's get back to our program here now. And what we first want to do is identify where those motors are. You can see the word motors has been highlighted here. And I'm just going to right-click on the screen and hit Create Constant. And you'll see that a constant has been selected. And I see that it's currently unselected, which is saying I don't know where your motors are. And so I can simply select one of my motors. Now, as I mentioned, we have a motor attached to both A and C, so we need to make sure that this particular function is controlling both, because in this particular case, we want our robot to go forward. So both of our motors are going to be moving the same direction at the same speed. So if I simply click this little down button right here, you'll see that a second output is now selected. I just have to identify where it is, and again, this was on Lego on port C. So you see you could actually attach 4 to this particular function. Now what you'll have noticed is that this part of the function has grown. We now have a red dot and a blue dot, which are associated with our red and blue modifiers. We've also seen up here that we can now specify the speed and power for each one of those two. Now speed and power ranges on a scale from -100 to 100. Negative values allowing the motor to spin in the opposite direction of which it naturally would spin. And just to note that forward and backwards are relative based on how you attach your motors to your robot. All right, now if we want to determine what our power and speed are for each one of these, we simply just need to right-click, hit Create, and go to Create Constant. A small number will appear. And in this particular case, I'm just going to put a value just for the sake of changing it. let's just set it at a value of -50. I'm doing this because I built my robot with my motors upside down, so forward and backwards are switched. I'm going to do the same thing for port C. Again, create a constant. We want this to go straight, so I'm going to set it at the same value that I set my port A, which is my red one right now. All right. And now I have the start of a program where my motors are going both in the same direction at a power level of -50, and I have designated that I am controlling ports A and port C. Now there's one other way to actually accomplish this goal. If we go back to our functions palette and we click on our complete palette, you will see that we have an option here for Lego motors. And here I can actually have a motor on, motor reverse, motor brake, so on and so forth. And so if I do drag my motor on function onto the screen, you'll see that it's slightly different, but for the most part it's the same. All right, if we look over in our context help over here, we see that we can identify what our outputs are. We have the same pink connectors for creating our function, and then we also are creating our program, and then we also have what our power level is. And you notice I'm only going to have to do this once. So now if I actually right click and I go to create constant, you'll see that right now it's selecting all ports, and I can select A and C together. Right? And again, now I don't have that red-blue option as I did above. I just have the one power level controlling both motors. And so I can simply select create constant again by right-clicking, and I can change my value to -50. And this will control both motors. Now in this particular case, since we have our motor going forward, this is a viable option. However, if you were in the case where you wanted your robot to turn and you wanted different power levels for your different motors, then you would want to use the first option. But in this case, both of these options will work just fine for what we are trying to accomplish here. Okay. So now using one of these, and it doesn't matter which one we use, we can then come back to our functions palette, and we want our robot to drive straight, and I'm just going to have it drive for a certain period of time. And so in order for it to drive for a certain period of time, we will now be using the wait for function. So I'm just going to click that and drag that onto the screen. And so we now have our wait for function. This is where those pink connector lines are going to come into play. We want this to flow from our motor on to our wait for function, and so we just simply take our pink wires and wire it up directly as such. And you can see when I look at my context cell for my wait for, you can have a function coming in and a function going out. Now our wait for allows us to wait for a variety of different things. In this particular case, we're going to be using time, but just so you're aware, you can have it where it is controlled by various different sensors. Right? Since we're doing time, and we've got it set for time right now, what I'm then going to do is look at my context help and identify what other modifiers I have, and it allows me to actually set the amount of time here in the bottom left-hand corner. So again, as we did before, we're just simply going to create a constant, and this allows me to determine what my time is. And we want to make sure that we're using the right units here, and we notice that it is in seconds. So let's say we have this drive for 2 seconds. Right. And so this is the entirety of my program. In order to have my robot drive straight at a certain power level, controlling certain ports for a certain period of time. And the way that this program is written is that these motors will go on, 2 seconds will elapse, and then the program will end because we don't have anything occurring after the program.